my gosh, I haven't run into one of these diagrams in a while. It's a lactic acid formation. Well, did you know that lactic acid is produced in your muscles during rapid exercise when the body cannot supply enough oxygen to the tissues? Without enough oxygen, the body is not able to produce all the ATP that's required. When you exercise vigorously by running, swimming, or riding a bicycle as fast as you can, large muscles in your arms and legs quickly run out of oxygen. So your muscle cells start rapidly beginning to produce ATP by this process. And it all takes place right in your muscle cells. But it only produces 2 ATP. Yeah, I bet you didn't know that. That's Mario. What the crap? How do we teleport here? This is weird. But it's a warp zone, so I guess I'll stay. Hey, and we found another diagram. This time it's on glycosis. Glycosis is actually one of the first set of reactions in cellular respiration. Glycosis is a process in which one molecule of glucose is broken in half, producing 2 molecules of pyruvic acid, a 3-carbon compound. When cells need energy with or without oxygen, glycosis occurs. Glycosis breaks down glucose to create 2 pyruvic acids. 4 ATP are produced at the end of glycosis, and the next stage of cellular respiration is the Krebs cycle. Well, I guess I'm going to take number 4. Oh my god, what? First person?
Take no prisoners. Woo! Ha! Yahoo!
Whoa, that block had a diagram in it. This time it's the Krebs cycle. The Krebs cycle is the second stage of cellular respiration. During the Krebs cycle, pyruvic acid is broken down into carbon dioxide in a series of energy extracting reactions. During the Krebs cycle, pyruvic acid from glycosis is used to make carbon dioxide, NADH, ATP, and FADH2. The names of the 2 phases in the Krebs cycle is citric acid production and energy extraction. The citric acid phase modifies pyruvic acid molecules from the glycosis process. The energy phase is called the energy phase because energy is released, and 2 ATP are produced from glucose. Well, let's see what other diagrams we run into. I don't think we'll run into any more, though.
Flag capture.
Whoa! I'm in real life now. What the crap? This stage is awesome. Hey, look! Kevin's doing a lab on cellular respiration. Let's check it out. The purpose of Kevin's lab is to observe aerobic and anaerobic respiration of yeast in an enclosed fluid environment, and in that way learn more about cellular respiration as a whole. What we believe will happen is that the yeast will use up all the oxygen available in the flask, and therefore start using alcoholic respiration, which means that it will be taking in no oxygen but release CO2. Therefore, the balloon will be filled with CO2 that is released as a byproduct of the alcoholic respiration and will inflate and possibly pop. Now let's see Kevin do his lab. We filled up the graduated cylinder with apple cider beforehand to get 40 milliliters. Hopefully.
Right there.
Okay, that's our lab. Done by Kevin Hong. Good job, Kevin. Hey, and I think I found the end of the stage. I found the end of the stage. 100 points.